In today's video, we are going to cover sections 5.4 and 5.5. We're going to talk about midsegments and triangle inequalities. So let's cover the definition of a midsegment. A midsegment of a triangle is the segment that joins the midpoints of two sides of the triangle. And when you deal with midsegments, you actually have three midsegments that occur within every triangle to form what we consider to be the midsegment triangle. So if I look at my example here, I've got triangle PQR. And let's go ahead and take a look at segment PQ. That's one side of my large triangle. I notice that X is the midpoint for that segment because of the two tick marks, meaning PX and XQ are congruent segments. So X is a midpoint. Well, if I take a look at segment QR, we notice that Y is a midpoint. So if I connect the two midpoints of the two sides of this triangle, what happens is we form this line segment, and this line segment is actually considered our midsegment. So XY is one possible midsegment. Since we have three midsegments, let's carry on. What if I talked about segment PR? Z is the midpoint for PR, so if I connected Z and Y, that would be another midsegment. So ZY would be a second midsegment. The third midsegment would occur if I connected midpoint X to the midpoint Z, and I would get XZ. So I have three midsegments there. They are segments joining the midpoints of two sides of a triangle. So our triangle that's considered our midsegment triangle would be triangle XYZ. So midsegments actually have a little theorem that go along with them. And what you have to realize is there are two important parts for this theorem. The first part says that a midsegment of a triangle is actually parallel to a side of the triangle. So if I look at my diagram, I notice that DE is indeed a midsegment of my triangle because D and E are midpoints on my two sides of this triangle. If I notice, my midsegment is actually going to be parallel to the side AC for the triangle. So that's the first part of the midsegment theorem that you have to realize. You've got a midsegment and it's parallel to one of the sides of the triangle. The second part that you have to realize is that the length of the midsegment is going to be half the length of that side. So when we look at this one, I notice that DE, the midsegment, is actually smaller than the measurement of AC. Of course, it looks that way, and it's smaller in such a ratio that DE is going to be half of the measure of AC, and that's why we have written here. So DE is half the measure of AC. Now let's go ahead and use that in the next couple examples. So in this first example, I notice that I've got a midsegment because of the hash marks that have marked my segments as being congruent. So I know X here represents the midsegment, and 38 ends up representing the side of the triangle. So we said that our midsegment, which is X, is going to be half of the parallel side of the triangle. So half of 38 ends up being 19, and that's all you have to do. So in the next one, if I take a look at this one, my midsegment is 15, and my side of my triangle that was parallel is X. So you always start off with your midsegment, and you say your midsegment is half of the side of the triangle. Well, in order for me to solve for the X here, we're going to go ahead and multiply both sides by 2, and when you do that, we're going to get X is 30. And that makes sense because your side of your triangle should always be larger than your midsegment. The last example we have here is slightly challenging. Not too bad, though, because we're dealing with a midsegment of 5x, and the side of the triangle is 8x plus 10. So I said start off with your midsegment. So we're going to start off with the 5x equals 1/2 of the side of the triangle. So half of the quantity, 8x plus 10. Now, I'm not a fan of fractions, so I'm going to go ahead and multiply both sides by 2. And when you do that, we will get 10x equals, now this 2 and this half will cancel, leaving me with the 8x plus 10. From there, you just solve normally, so we subtract 8x from both sides. I get 2x equals 10, so x is 5. What a good thing to do with problems like this would be is take this 5 and shove it in. So if I take 5 times 5, I notice that the measurement for the midsegment would be a 25. If I go ahead and throw that 5 into this side of the triangle, 8 times 5 gives me 40, plus 10 gives me 50. Does it make sense? Yeah, because my midsegment is half the measure of the side of the triangle. Another way in which I can ask you problems dealing with midsegments is to give you a diagram like this, and then just ask you for specific segments or angles. So the first one asks for the measurement of segment BD. Now I know segment BD is a midsegment of the triangle, and anytime I'm looking at this midsegment, I want to be able to then compare it to the side of the triangle that would be parallel to that. So the side of the triangle that is parallel to that midsegment is AE. And we said the midsegment is half the measure of the side of the triangle. So BD would equal 1/2 the side of the triangle that would be parallel to it, which is 17. So half of 17 gives me 8.5. Next, let's go ahead and take a look at the angle CBD. So if I'm looking at the measure of angle CBD, CBD is that angle right there. Let me actually highlight it in blue. C to B to D. Now the hard part about this is just being able to find another angle to get some information based. So if I'm looking at this diagram, do you notice how we've got angle FDB labeled, and that is 26 degrees? If I take a closer look at this, remember, the midsegment, in this case FD, is parallel to the side of the triangle AC. So if these two segments are parallel, hopefully you'll notice we end up getting alternate interior angles. So if I get alternate interior angles and lines are parallel, I know those two angles are congruent. So if angle FDB was 26, so should angle CBD. So we get 26 degrees. Why don't you go ahead and try this problem out on your own? You need to find JL, PM, and the measure of angle MLK. Do it on your own. Pause the video, and when you're all ready, go ahead and start it up again, and I'll have the answers written down for you. So let's go ahead and take a look. Hopefully, for JL, you ended up getting 72, and here's the reason why. I'm looking at JL, and that's the side of the triangle. So the best way for me to figure out how much that is to look for the midsegment. The midsegment, PN, is 36. So if the midsegment is 36, and we said that the side of the triangle, if I take half of that, I would get the midsegment. So if I'm working from the midsegment to the side of the triangle, I'm actually going to double it. So my JL should end up being 72. PM is the next one we're looking for. So if I'm looking for PM, the side of the triangle is 97. So the midsegment is half of the side of the triangle, and half of 97 is 48.5. The last one asked for the angle. So we're looking at angle MLK. So we're looking for this angle right here. Well, the only other angle that I have labeled is angle JMP. If you take a look at this, these two angles actually form the letter F. And we know from previous, the theorem that we covered in the first couple slides was the side of the triangle is actually parallel to the midsegment. So these two segments are parallel, which means my corresponding angles are congruent. So if angle JMP was 102, that means angle MLN is also 102. So in this example, we are talking about triangle KLM, and they said it was a midsegment triangle. So as soon as I know it's a midsegment triangle, I know that KM, ML, and KL are all midsegments. I want to find out what the perimeter of the larger triangle is. So if I want to find the perimeter of GHJ, I already know 2 out of the 3 sides of this triangle. So let's talk about this. Perimeter. Let me see if I can write this. Perimeter of triangle GHJ. Well, I would take 12 and I'd add 11 because those are the 2 sides of the triangle that we already know. The one side that is missing is this one right here. So if I'm trying to look for the segment GJ, the side of the triangle, the best thing to do is look for the midsegment. The midsegment that belongs to that side of the triangle is KL, and the midsegment is 7. So if the midsegment is 7, we know that the side of the triangle should be 14, because the side of the triangle is double the midsegment, or the midsegment is half of the side of the triangle. So once we've got that, all you have to do is add them up, and we end up getting 37. Now, when we talk about triangles, there are certain things that occur with the relationships between their sides and their angles. So the first thing we're going to take a look at here says, if two sides of a triangle are not congruent, then the larger angle is opposite of the larger side. So in a triangle, if I'm saying that, say, segment AB is larger than segment BC. So this side of the triangle is larger than this side of the triangle. That automatically means that the angle opposite of the longer side is going to be the larger of the two angles. So angle C is actually going to be larger than angle A because it's across from the longest side. Also, it works in reverse. So if I'm dealing with two angles in the triangle that are not congruent, then the longer side is going to be opposite of the larger angle. So in this case, we're saying that angle Z is actually larger than angle Y. So if angle Z is larger, that means the side opposite of angle Z, which is XY, should be larger than the side that is opposite of angle Y, which is XZ. So the relationship stands. Whatever I've got for a side, the longer side is across from my largest angle, and my larger angle is across from my longest side. Let's go ahead and put that into practice. So the first example here asks us to write the angles in order from smallest to largest. And pay attention to that because that can sometimes switch up. It could ask from largest to smallest, or they could ask for sides. So in this case, we're looking for angles. So what I'm going to do is I'm going to put angle, angle, and angle down because I know I'm looking for angles. Now I want to list them in order from smallest to largest. So the smallest angle should occur from across from the smallest side. In my diagram here, I notice my smallest side is side FG, which is 17.2. Therefore, the smallest angle should occur across from that. So my smallest angle is going to be angle H. The next smallest side in this diagram occurs at GH. So if my next smallest side is 19.6 GH, that means my next smallest angle is angle F. And lastly, the largest side should occur, or the largest angle should occur from across from the largest side, and my largest side was FH, so my largest angle is going to be angle G. So I can do that with angles, or like in the next example, we can go ahead and write the sides in order from shortest to longest. So we're going to write sides, so I'm going to put little segment bars, so remember I'm talking about sides and not angles. Now the issue that I'm going to run into in this problem is I currently have 2 out of the 3 angles listed. So if I only have 2 out of the 3 angles listed, I really do need to figure out what this third angle is to be able to compare things. So let's look at this. I know there's 180 degrees in a triangle. So if I take 180 and I take 60 and 72 away from 180, I will be left with 48 degrees. That's how I'm going to figure out that third angle. Once I've got the third angle, now I can do the comparisons. So I'm writing the sides in order from shortest to longest. So let's go to the smallest angle. The smallest angle is at K. So if the smallest angle is at K, that means the smallest side would be opposite of that. So my smallest side would be segment PQ. The next smallest angle is P. So the side opposite of that is segment QK. And the largest side of the triangle would occur across from the largest angle. So the angle Q is the largest, so that means PK is my largest segment. Now you might be saying, well, it doesn't look like that in the diagram. It actually looks like maybe PQ would be actually larger than QK. You can't go based off of what the diagram looks like. Go based off of what the numerical values are. So we all know that when I try to form a triangle, you need 3 segments to try to form a triangle. But not every set of 3 segments can actually come together to make a triangle. For example, in the first example that we have here, we've got segments of lengths 4, 4, and 7. And I can put them together to form a triangle. But what happens if I had, say, segments of length 3, 3, and 7? When I try to put those together, no matter how I might try, there's no way in which I can form a triangle. So that kind of leads us to the next theorem. Our triangle inequality theorem states that the sum of any 2 side lengths of a triangle should always be greater than the third side length. So no matter what 2 sides of the triangle I may choose, if I add them up, they should always be larger than the third. That's how I know I should end up getting a triangle. If that isn't going to happen, if I end up taking two sides of a triangle and it's not greater than the third, then I cannot make a triangle. So for this example, we're going to try to tell whether or not you can actually have a triangle with the given side lengths. So in the first one, they are giving me that I've got 3, 4, and 5, and those are the three side lengths that I'm trying to utilize to make a triangle. The easiest way to figure out whether or not I can make a triangle is to do the following steps. If you take the two smallest sides out of these three numbers, which are 3 and 4, if you add the two smallest sides together, it should be greater than the third if you can indeed form a triangle. So 3 plus 4 ends up giving me 7, which is greater than 5. So if it's greater than the third side, then I know I have a triangle. So in this instance, you would say yes. The next problem, if I'm looking at it, I've got 7, 10, and 14 possible side lengths for a triangle. Let's see if I can make a triangle. The two smallest sides are 7 and 10. So what we're going to do is we're going to take 7 and add it to 10, and we're going to see if it's greater than the third side. So if I take 7 plus 10, we'll get 17, and is 17 greater than 14? Yes, it is. So we can indeed form a triangle. The last example, if we take a look at it, I've got 5, 8, and 13 as possible side lengths. We're going to take the two smallest sides. So we're going to use 5 and 8. We're going to see if it's greater than 13. So 5 plus 8 gives me 13. Is 13 greater than 13? No, it's not. It's actually equal. But we don't have an equal to bar underneath with that inequality, so we're going to say, no, I cannot make a triangle. The last example we're going to cover has to deal with the length of two sides of a triangle. In this case, they are giving us 8 inches and 13 inches. So our job is to find the range of possible lengths for the third side. So I want to know, what does that third side have to sit between? What numbers are possible for us to get a triangle? So what I want to do is I'm going to take these two values, 8 inches and 13 inches, and to find the smallest possible side length that the third one could be, we're going to take those two values and we're going to subtract them. So if I took the larger of the two, I've got 13, and I subtract off the 8, we're going to end up getting 5. That means my third side has to be greater than 5 in order for me to be able to make a triangle. The last thing we're going to do is we're going to take those two side lengths and we're going to add them. So if I take 13 and 8 and add them, I'll get 21. So that means the third side has to sit between 5 and 21 in order for us to have a triangle. So make sure that if I ask you what is the range for the third side, you subtract the two values to get the lower number, and then you add the two values to get the larger value. If you got any questions, make sure you write them down and you ask us tomorrow. Until then, have a great night.